Alright class, so today we're going to talk about how to solve systems by graphing. And before we go into what it takes to graph these equations, let's talk about what a system is. A system is two or more equations that we're going to graph on the same coordinate plane. Okay, so just like we did in our last lesson where we had to graph one line, we're now going to be graphing two lines. Okay, so this lesson actually combines with the last lesson that we covered. So the way that we graphed lines before is going to be very similar to the way we're going to graph these lines in this lesson. So let's go on and talk about the types of solutions that actually can be made when we graph a system. Okay, because we are graphing two lines, there's three types of solutions that could possibly be shown. And the first type of solution that we're going to go over is going to be a one solution. Okay, so to break down one solution, just to give you an idea, when we graph two lines, what's going to happen is this. When we graph them, no matter the direction that they go in, you will see they're going to look similar like an X. But what happens is this. They cross at one point. Okay? And that one point that they cross at is going to give us an ordered pair of X and Y. That's why they call it a one solution, because it's crossing one time. It will cross nowhere else but at that one point. Okay, so that's going to be a one solution. The next type of solution that we could possibly see is called an infinite many. Okay, so infinite many solution. Infinite many, if you really think about infinite means unlimited. So if I have an unlimited amount of times that we're going to cross, the way we can identify infinite many is when we graph those lines, we're actually graphing that exact same line twice. So there's going to be a match. So if we're graphing exactly the same line twice, then that's going to be an infinite many solution. And then the last one that we got that we're going to go over is going to be a no solution. So in a no solution, when we go to graph those, if you think about it again, no. So if I think about no, that means no points will actually cross. So when I see this, when I got two lines being graphed, they will never touch. Okay, so basically what we call that is parallel lines. So if no lines touch, or neither one of the two lines that are graphed cross, that is a no solution because they're exactly two parallel lines. So the first one solution, cross at one point. It kind of look like an X. Infinite many, with those they touching the same spot every time. They have an unlimited amount of points that's going to cross. Infinite many. Then if you see that they look like two parallel lines and they will never touch, that is a no solution. Okay, so these are the three types of solutions that we're going to see in systems. Okay, so now we're going to look and see what we have to do in order to solve these systems. So with systems by graphing, step one is that we're going to graph the lines. Okay, so we learned in the last lesson, in order for us to graph the lines, we have to have our slope and y-intercept. That is our m and our b. Okay, so when we graph that, those two things, we can graph both lines and we can go from there. But remember, there was two methods in that last lesson. So the first method is when we use m and b. That's going to be the most common. Okay. The second method is that we can have a set of points, or we can make tables for each equation, plot those points, and then see where it crossed. Okay. So whatever method you choose is your choice, but the most common one is the first one, where we use slope, rise over run, and our y-intercept, which is our b. Okay. Then step two is then once we graph both of those lines, we're going to identify the solution. Okay, so whether it be a one solution, infinite many, or no. Alright, so if it's a one solution, we're going to get ordered pairs. Alright, where the lines actually cross. If it's an infinite many, that's the same line, we'll write infinite many. If it's a no solution and never cross, we'll write no solution. Okay, so now that we got a baseline about how to do systems, let's look at a couple of examples. In my first example, it says a system of equations is shown below. We got y equals 2x minus 9 and y equals negative x plus 3. What is the solution to the system of equation? So with us having to find the solution, what we're going to do first is we're going to label our first equation. We're going to label that one as being my y equals 2x minus 9. And then my second equation, that's going to be y equals negative x plus 3. I'm going to graph the first equation in black. So I'm going to label my m and b first. Okay? So we know my slope in this one is a positive 2. So I'm going to go ahead and make it a fraction by putting 1 under it. And then my y-intercept is negative 9. So once I identify my slope and my y-intercept, I'm going to go graph it. So I start at my y-intercept on my y-axis at negative 9, put my dot. Then from there, having that dot, I'm going to go from here, count up 2 lines, over 1. Okay, because it was positive, I went up. And then from there, I went over 1 because that 1 was positive, so I drop a dot there. Now from my last dot, okay, I count up 2 lines, over 1. So I'm going to do that like we did before until I run out of graph. So I'm going to go ahead and graph the remainder of my dots. Until I run out of graph. Okay, now my first line is graphed. Now I don't know where these 2 lines may intersect, if they intersect at all, but just know with systems, at some point it could possibly cross, and that's what I'm looking for every time that I graph a system. Now in my equation 2, I'm going to graph that one in red. Let me go ahead and identify my important information, like my slope. My slope in this one is a negative 1. I'm going to go ahead and make it a fraction by putting 1 under it. My y-intercept is a positive 3. Okay, so on my graph, I'm going to go ahead and graph my y-intercept, positive 3. Then from there, I look and go from that point, count down 1 because it was a negative 1 at the top, and then over 1. So I put that graph, that dot. So from my last dot, count down 1 line, over 1 line. Now I'm going to continue to do that until I notice if those 2 actual graphs cross. So whenever we see an overlap of the dots that we made, that's the point of intersection. So my point of intersection happened here. This is where they cross. Okay, because that's where they cross, that's my answer. Now that point is my answer, but that point also gives me an order pair. So the order pair that it gave me, because I'm going to need an x value and a y value. That's an order pair, okay? So the order pair that point gave me based off the solution was a positive 4, negative 1. So the answer is going to be positive 4, negative 1. That is my answer, and that's how we find the solution to a system, is based off if it's crossing or not. So when I look at my answer choices, 4, negative 1 will be the choice that I will have to choose because that's where they cross. In my second example, it says a system of equations is shown below. Y equals 3x minus 3 and y equals 2x plus 1. What is the solution to the system? So I'm going to go ahead and label my equations. The first one, I'm going to go ahead and graph. So we got y equals 3x minus 3. Okay, with that one, we're going to label m. M is going to be 3. But I'm going to go ahead and make it a fraction by putting 1 under it. Okay, slope has to be a fraction. My y-intercept is negative 3. Okay, so I'm going to start with my y-intercept on my y-axis. So I go to my y-axis, skim down to negative 3. That's where I put a dot. That's where I start. Okay, so from that point, I'm going to use my slope to get to my next point. So from here, because it was a positive, it's a positive 3, I got to go up 3 lines, over 1 line. Okay, and I'm going to do that just like we said before until I run out of graph. So I'm going to count up 3 lines, over 1 line, up 3 lines, over 1. Because my rise was 3, so 3 lines up, over 1. Now I'm out of graph, so I'm going to stop there. Okay, now from that point, I'm going to go and graph my second equation. Second equation is y equals 2x plus 1. So I'm going to label my m. My m in this case is going to be positive 2, but I'm going to make it a fraction by putting 1 under. My b in this one is a positive 1. So that b, by it being positive 1, that's where I will start. Go ahead and drop my dot. Okay. Now with that dot being there, I'm going to go up 2 lines to the right 1. So count up 2 lines over 1. That's where my next dot go. Okay. So from there, count up 2 lines over 1. That's where that one go. Count up 2 lines over 1. We see that they're getting close together, but they haven't really touched yet. So we keep going until we run out of graph. Okay. And at that point, that's where the 2 dots meet. So they cross here. Okay. Because they cross here, that is my solution. But remember, the solution is not the actual 2 points. The solution is the order pair. So I have to get the order pair from those 2 points where they crossed. So an order pair gives me an x and a y value. Okay. So if I go back to the point where they crossed, that order pair is 4, 9. So the solution or the answer is 4, 9. So when I go to look at my answer choices, I'm looking for 4, 9. Alright, so that is the answer to that one. In this third example, this is also my final example. It says a system of equations is shown below. We got y equals 2x minus 1 and y equals negative x plus 2. It says what is the value of the x in the system of equations. So if we're looking for the value of x, that's the only one we focus on, but we need the entire set of order pairs. Okay, and then we'll identify the x once we get that. So in my first equation, we got y equals 2x minus 1. So my m is going to be 2. So it's not a fraction, so I'm going to go ahead and make it a fraction. My b is negative 1. So I'm going to go to my graph negative 1, meaning I go to my y-axis to negative 1, put a dot. Okay, now from there, because it's a positive 2, I count 2 lines up. So there'll be 1, 2, and over 1. Okay, now I'm going to do that until I actually run out of graph. So 2 lines up and to the right 1. 2 lines up to the right 1, 2 lines up to the right 1 until, like I said, I run out of graph. I'm out of graph now. So my first equation has been graphed. Let's look at my second equation. So for number 2, we got y equals negative x plus 2. Okay, where my m is equal to negative 1. So I'm going to go ahead and make that a fraction by throwing a 1 under it. Alright, and my b is at a positive 2. Alright, so I start at positive 2. My slope is negative 1. So that because it's a negative 1, I go down 1 line and then to my right 1. Okay, so I see my overlap there. I just want to be sure. So I drop me another dot, following the pattern, down 1 to the right 1. So my solution in this case, as soon as I found that solution, I can stop. So that means they crossed here. Okay, so because they crossed here, that's the same order pair for both of them. That's the one we're going to find. So we need an x value. So my x is going to be equal to, my y is equal to, that's an order pair. So you know every order pair has an x and a y. Okay, just listing what they are. So my x value was 1. My y value was 1. Okay, so in this case, because it only asks for my x value, my answer is going to be 1. Okay, so that is the solution to this one. X is equal to 1. Okay, so in this actual lesson, ladies and gentlemen, we covered how to graph systems and how to find solutions. We covered that there are 3 types of solutions, where we have one solution, infinite, many, and no solutions. Okay, so if the lines never cross, that's a no. If they always cross, that's an infinite many. And if they cross at one specific point, like the 3 examples that we have, that's a 1 solution. But with 1 solutions, we have to get order pairs for, okay, because they cross at that specific spot. So that covers how to graph system of equations and how to find their solutions. Now it's your turn to practice.